We're in the Brain Observatory now, and what we do essentially is transform biological specimens. We work with brains and transform these brains from tissue into data. So it is a process of virtualization. I was fascinated by the actual organ itself. And then I learned the technique of slicing a brain, I learned the technique of staining the tissue, learned the technique of creating the histological preparation, which I had already done in Italy when I was a student, but this we're talking now about the human brain. It was really a different level. So I really became interested in the fabric of the human mind, because I knew it was there, you know. And that gradually this concept was refined over the years. But I stayed true to my original fascination with the actual organ, the brain as an organ, and not so much as pixels and voxels. In the process of virtualization, that's the challenge. Turning something wet and bloody and soft and so fragile into hard data that can be explored. That's what I'm really excited about these days. I think as a home, the Cal-IT2 Qualcomm Institute is perfect, because we kind of, now I want to give this new twist to old-time morphology and anatomy and histology. I think, you know, Qualcomm Institute is the perfect place to do it, because then we can have colleagues there who can show our images on an enormous display, or build together a 3D printer that we need maybe to really tackle this very convoluted biological object like the brain, you know, this type of challenges. So it's a nice balance, I think, between history, tradition, biological questions, and digital technologies, and material science too. In the end, what I would like to do is to have a detailed enough blueprint that we can reprint the brain of a person, and that it could be the scaffolding for, you know, neurons to grow and recreate this person's mind. I mean, that's kind of very ambitious.